Okay, so today we're going to learn about scientific notation. Now, I'm not going to spend a lot of time on this in class. This is going to be your main tool for teaching you this. I'll spend a few minutes in class reviewing it real quick, but the task of learning it is on you. And we're going to need this for later on to do calculations in class, and you're going to also need it later on when we learn physics and other mathematics. So this is just a quick tutorial on how to do this. So scientific notation is a shorthand methodology for writing very large or very small numbers. The numbers can either be positive or negative. Examples of some very large numbers. Here's one example right here. There's a lot of zeros, 10, 3, 4, 3, 6, 9, 12, 15 zeros. And then here's a very large negative number with 9 zeros. Very small numbers, numbers between 1 or negative 1 and 0. You can see here that this is a very small negative number, quite a few zeros there, and then quite a few zeros on this number here. The advantage of it is that it allows easier manipulations of numbers during calculations, and if you know how to add, subtract, multiply, and divide exponents, then it's easy to do this method way than as far as trying to figure out how to do it in longhand or expanded form. And it's generally more reliable when you're entering it into a calculation or your calculator. You can't forget number of zeros, or you're not limited by the screen length in your calculator. This would be very hard to enter in a calculator. There's just not enough characters on your screen to make sure you've entered all the zeros. So that's one of the advantages of using scientific notation. So let's see how we do it. So what is a number in scientific notation? It's just a number described as a power of 10. And there are two formats that you will see most commonly. Format 1 is the most common one, is m times 10 to the nth, where the absolute value of m is a number that is greater than 1 and less than 10. Right? So m times 10 to the n. N is the number of times that 10 is multiplied. It raises 10 to the nth power. So if 10 times 2, 10 to the second means 10 times 10. N must be a whole number, a whole integer. 1, 2, 0, 3, 4, etc., etc. They can be negative, but they can't be fractions or decimals. M can be negative, just that the absolute value of it has to be greater than or equal to 1 and less than 10. The number itself can be negative, and it can be a decimal. So let's look at a couple of quick examples. How would we write 1,000 in scientific notation? Now you would say, well, why do you need to write 1,000? That's easy to enter in your calculator. And you'd be right, but we could break it down into the following. 1,000 is just 1 times 10, which would give you 10, times another 10, which would give you 100, times a third 10, which would give you 1,000. So the way to write it is 1, in which 1 is greater than or equal to 1, times 10, and how many times did I multiply 10 by itself? 3 times, right? The other way you could write that is, in that same format, is 1 e to the plus 0, 3. E stands for exponent, plus 0, 3 stands for n, right? Now why am I going to write it plus 0, 3? It's the format I use to make sure that you're not confused that it's not 1e minus or plus 3. So when I see it this way, my brain starts to think, oh, that's scientific notation. So let's look at an example that has a negative value. So the negative 0.002. So how can I represent that in scientific notation? So the best way to do that is, first of all, I have to find my m value. And since this case we only have one number, that's the 2, right? I can say that that's going to be my value. So I'm going to put 2. I'm going to put the negative with the 2. Now to get negative 0.002,
I would just take my negative 2 here and multiply it by 0.1 times 0.1 times 0.1. So if you do this on the calculator, you'll see you're going to get 0.001. Then when I multiply that number by negative 2, I get negative 0.002. Now, look at this here. 0.1 times 0.1 times 0.1. They're all the same. And recall that we can represent 0.1 by being 1 over 10, or another way to write that is 10 to the minus 1. So 10 to the minus 1 is the same as 0.1. So if we write this out this way, we'd have negative 2 times 10 to the minus 1 times 10 to the minus 1 here times 10 to the minus 1 here, or as it's written here, which was 10 to the minus 3. So that is how you would write a negative number and a number that is less than 1 but greater than minus 1.
All right, so let's learn how to convert an expanded number or a normal number into scientific notation. Now, the first rule is we look at our number and we find the place within that number where if we put a decimal, it would give us an m value, that the absolute value of that m value is greater than or equal to 1 or less than 10. Remember, the m value can be negative, but the absolute value of it has to be greater than or equal to 1 and less than 10. Once we have put that decimal in that position, we are going to count how many places we have to move the original decimal to reach this new position. The number of times that you move the decimal is the number of times you have to multiply by 10. This is going to be your n value. Now, if you move the decimal to the right, then n will be negative. If you move the decimal to the left, then n is positive. Okay? So let's look at a couple of quick examples here. I'm not going to do all these. I'm going to do a couple of them, and I'm only going to do one with both formats, right? So let's look at the first one. The first one is 0.005. So where do I have to put my decimal to make this number here, and the m value, greater than or equal to 1 and less than 10? Well, let's just look at this now here. Where it is right now, is that number greater than or equal to 1, less than 10? No, it's actually less than 1. If I move the decimal here, that's 0.05. That's still less than 1. If I move the decimal here, that's 0.5. That's still less than 1. However, if I put the decimal here, that's 5 point. 5 point is greater than 1. It's less than 10, so that's where I'm going to put my decimal. So let's put that right there. Now, how many times do I have to move the original decimal spot, which is right here, to get to this position? Let's count them. 1, 2, 3. So I moved it 3 times. So n equals 3 at least. We know the n is going to be some value of 3. Did I move it from left to right or right to left? I moved it from this direction, so it's left to right. So I moved it to the right, so n will be negative. So it's a negative there. So when we write my thing out now my new one is going to be 5, because that's where my new number is, 5 times 10 to the negative 3. The other way I could write that, and I'm only going to do this example once for this, I'm not going to do this anymore, is 5e to the minus 0.3. Again, why did I put a 0 here with the little line through it? Because it's telling me that it's e to the minus 0.3 and not e to the Some people will write it this way, e minus 3, 5e minus 3, and I always say, well, that could be confused with an equation. But when I do 5e to the minus 0.3, that my brain tells me that's not an equation, that's scientific format, right? So I'm only going to do this format right now for one of these, right? So let's look at one more real quick, right? And next one is, let's look at 5,050. So 5,050, where am I going to put the decimal to make that work, right? So the decimal right now is here, right? It doesn't show it, but that's where it is. So if I move it here, it's 505. If I move it here, it's 50.5. And if I move it here, it's 5.05. Is 5.05 greater than or equal to 1 and less than 10? It absolutely is. So how many? So I'm going to put my decimal there. So let's just put that decimal right there. Now, how many times do I have to move it? So the decimal was here, so it's 1, 2, 3. I moved it 3 times. So n again is going to be 3. But this time I moved it which way? I moved it from right to left. So I moved it to the left. So that means this is going to be positive. Now I have to write the whole number now because it's not just 5 anymore. It's 5.05. So I have to write 5.05 times 10 to the third. That's a 3, sorry. All right. Now I'm not going to do this one here because it's very similar to this one. You can try it. But let's look at this 1,000 here. So the 1,000 is going to throw you for a little bit of a curve here, right? It's minus 1,000. So what am I going to do here? It says here my value has to be greater than or equal to 1 or less than 10. No, remember, it's the absolute value of the m. M can be minus a value. So let's, again, look at where we're going to put our decimal. Here's my decimal, the first one. That's where it normally is right now. If I move it here, it's minus 100. If I move it here, it's minus 10. Right here, it's minus 1. So that's where I want to be. So let's put our decimal right there. Now, how many times did I have to move it to get to this position? 1, 2, 3. So n, and I moved it from right to left. So I moved it to the left, so n is going to be plus 3. Well, wait a minute, you said, well, it's minus. How can it be plus 3? Remember, it's a large negative number. It's not a small negative number. So now we just write minus 1 times 10 to the third. And there you go. So that's how these work, right? Now you can do the last one, the million, by yourself, right? Count how many decimal spots you're moving. That's your n value. If you move it to the left, you're going to be positive. If you're going to move it to the right, you're negative. Don't forget to write the whole number. If you have 5.05, you got to write that whole number, 5.05. Okay, so now we want to go back from scientific to expanded. Now everything is in reverse, right? So if you moved it to the right, now you're going to move it to the left. If you move it to the left, you're going to move it to the right, right? So everything is in reverse. So the way this works is very simple. This is actually more intuitive than the going from one to the other. So we just put we already have the 1.5, so let's do that, right? My 3 tells me what? How many times I have to move the decimal. And now, instead of moving it, if I'm moving it to the right, I was going to be negative. Now when I move it to the right, it's going to be positive because we're going the opposite direction. We're going from scientific to expanded as opposed to the other way around. So let's look at that. So we just got to move it 3 times. So that's 1, 2, 3. So we put our little thing there, and we just fill in all the blanks with zeros. So we just fill in all the blanks with zeros, and then we get rid of this thing here. So our final number is 1,500, sorry. Look at the next one here. Again, we're going to put that here, 1.5. This time it's minus 3, so which way do we go? We go the other way. 1, 2, 3. So we put in zeros. And then we also have to put a 0 in front of the decimal. And so our final number is 0.0015, right? So I think you're starting to get the hang of this, right? So let's just do one more here real quick. Let's do this 375. So we just put 375, 3.75, I'm sorry. And it says we're going to move the decimal twice, so we move it once, twice, and so the final number is 375. right? And the answers to this one would be 2200, and this one would be 0.0375. So that's the answer to that one, and that's the answer to that one, and that's the answer to that one. So you can see it's just a matter of moving the decimal the number of times it says so here. And if it's plus, you're going to move it to the right. If it's minus, you're going to move it to the left. And it's that straightforward. This is how many times you move it. And then this minus and plus just tells you the directions. Okay, so you're just going to fill in the chart here. Now I gave you a little bit of a curveball here. I put you here, right? Just remember the E. You could just write this as 10 times to the minus 10 to the minus 3, right? So you're going to fill that in. So if you've run any of my slides or videos before, you can see that I ask you to do this here as a self-check. So you're just going to fill in the table for the missing pieces of information, and when you're done, you're going to check your answers. All right, so copy the information down, stop the video, work the problems. When you're ready, start the video. Stop the video now. All right, so here are the answers. Hopefully you got most of them right, if not all of them right. Again, I said that we're not going to spend a lot of time on this concept in class. So if you're still struggling, you can either come find me and I can help you through it. You can go back and review the video in your textbook, your notes, or you can ask a classmate to try and help you out. But I would try to work it out yourself first. If you're still stuck, come find me, and then I'll get you back on the right path.